everyone, and welcome to the lecture number 2 on Matplotlib library. And as you know, my name is Aayush Porwal, and I hope you guys are doing well. So till now we have covered basic stuff related to Matplot library, which contains mostly the plot function, the plot method, the show method, and a lot of things like scatter plot, what is scatter plot, and what is subplot, all these things, the pie chart, histogram, bar, and all these we have covered till now. And I hope you guys must have submitted your assignments. If not, try to submit it as soon as possible because it will give you a better insight on build a concrete knowledge about Matplotlib library. That particular part is very important, and try to submit it as soon as possible for those who haven't submitted the assignment yet. So in this particular lecture, we'll be looking at firstly stack plot, and I think I'll be able to teach you guys some very basic stuffs related to Seaborn library as well. So without further ado, let's jump on to the very first topic, that is stack plot. So what is stack plot? Stack plot is used to draw a stacked area plot. Always remember that we are trying to draw a stacked area plot. It displays the complete data visualization. It shows each part stack onto one another, and how each part makes the complete figure. Okay, so it displays various constituents of data and it behaves like a pie chart. It has label, X label, Y label, and a title in which various parts can be represented by different colors. So all in all, the idea of stack plot is to show parts to the whole over time. It is used to represent various data sets without overlapping over each other. I guess it is well understood, and if not, I'll first teach you what this code is all about, and later on, when I run this particular code, you'll get the better insight of it. Okay, so as you know, we have to import Matplotlib PyPlot library as PLT, and we are also importing NumPy as NP. We are making an array from 1 to 5 and we'll store this data particular into days. Okay, similarly we are storing the data into sleeping, studying, and playing. Okay, now in order to make a stack plot, we have to use a particular method, that is plt.stackplot, and in here we'll be passing days, all these parameters, sleeping, studying, playing, as well as, let's first ignore this particular thing, and okay, let's ignore this particular thing, gonna cut it. Okay, so we'll be passing days, sleeping, studying, playing, all these parameters, and we are passing color for each of the 3 parameters. Okay, so that is hot pink for sleeping, cyan for studying, and red, let's write red only, for playing. Okay, and let's comment this particular part. I'll be passing X label as days, Y label as number of hours, and the title of this particular figure as a representation of studying, sleeping, and playing with respect to days. Okay, and we are showing this particular thing. Now let's run this particular code. So this is what we are getting. We can see that let's sum this particular thing. 7 plus 2 is 9, 9 plus 8 is 17. Okay, so it is somewhere here 17, and this particular thing shows that from 0 to somewhere here, that is 7, we are sleeping. And in order to detect what is this particular pink thing, what is this blue thing, sorry, cyan thing, and what is red, we use legend. We know that. Okay, so it will basically determine which color is which. Okay, it will label them. So let's quickly run it again, and you'll see that now we are getting pink denotes sleeping, cyan denotes studying, and red denotes playing. Okay, so I hope till here it is clear to you guys. Okay, so now this is all about stack plot. Now we can change the baselines as well. So here we can see that by default the baseline is 0. We can make it a symmetric baseline as well. So let's quickly run this particular thing, copy, paste. So now you can see that it is symmetry. It is a little bit symmetrical figure. We can see that the baseline we have choose is symmetry, and also we can use wiggle. You can try it, and if you, at all you have any doubt, you can ask me, as well as you can search it in Google. Everything is available in Google. Okay, so yeah, just do one thing, just search it. If at all you guys are facing any trouble, then you can come to me and ask me, and I'll definitely able to clear your doubts. Okay, so this is all about stack plot. So I hope you get the clear-cut understanding what stack plot is. Basically what we are doing is, this is the important thing, the idea of stack plot is to show parts to the whole over time. Okay, it is used to represent various data sets without overlapping over each other. Okay, it is not overlapping, it is stacked together. This particular thing is sleeping, this particular thing is studying, this particular thing is playing. How we do it? We have to use this particular method, we have to pass these parameters. Okay, so the next topic is box plot. It is very interesting. So a box plot is also known as, first of all, a viscous plot, because we can see from the figure that these are all the whiskers of it, and this is the mouth. So it's kind of also known as a viscous plot. So what it is? A standardized way of displaying the distribution of data based on 5 summaries. Okay, this is very important, displaying the distribution of data based on 5 summaries. So a summary of minimum, a minimum value of if a particular thing is stored in array, what is its minimum value, what is the first quartile, what is the median, what is the third quartile, and what is the maximum. Okay, so this particular figure shows that this particular line, first of all, this particular line represents the minimum value, this particular line represents the maximum value, this thing represents the median, and this particular thing represents the first quartile, that is 25th percentile, and this particular thing represents 75th percentile. Okay, now let's take an example how we can do it. So I have to add, yeah, so let's say we have a data, okay, let's say 10, 50, 20, 30, and what, yeah, 40. So the size of this particular, length of this particular array is 5. What we have to do, first we have to sort this data. So the sorted data will be first of all 10, then 20, 30, 40, and 50. Now the minimum value, it is very easy to calculate. The minimum value will be 10, so the maximum value will be 50, the median will be 30. Okay, all you have to do is you have to sort the value. You have to the first value will represent the minimum, the last value will represent the maximum, and the middle one will represent the median of it. Okay, now in order to calculate, in this particular case it is very easy to calculate that 20 is the first quartile, and these 40 is the third quartile. Okay, that is 25th percentile and 75th percentile. Now if you have some other data, what you can do is this particular code will come in handy. So this particular code will give you what is the minimum value, what is the quartile value, and what is the maximum value. Okay, so in this particular case, let's take this particular example and let's try to run it. Okay, let's copy paste. Yeah, so we can see that 10 is the minimum, 50 is the maximum, 20, 30, and 40 are the respective quartile values, that is 25th percentile, 50th percentile, and 75th percentile. So I hope it's clear to you. Okay, and now coming on to a box plot. I hope you get the understanding of what box plot here it is. Okay, so now we are passing some random numbers here. Why not let's calculate all the quartiles of this particular thing first. Okay, so that it will be very easy to correlate. Yeah, so we got these things. Now let's try to plot it. What we have to do in order to make use of box plot, we have to use a method that is plt.boxplot, and we have to pass the parameter pass the argument as x, which contains the data in the form of an array. Okay. Now, similarly, we are mentioning the labels, the x label, the y label, the title, and we are showing it. Okay. Let's copy and paste it somewhere here. Okay. We're not doing anything else here. Okay. Let's run this particular code. Yeah, so you can see that the minimum value what we get here is 10. Okay, so it is 10, right? The first quartile, that is 25th percentile, is 18, so 18 is here somewhere. This particular line shows the median of it, so the median is 32. You can see that it is slightly greater than 30, so this particular thing lies somewhere here. So it is 32, and 42.5 is will be somewhere here. So you can see that the third quartile lies somewhere here, and this is the maximum value, that is 60. Okay, so I hope you get the basic understanding of it. Similarly, we can do it for the data, that this particular data, right? We'll copy it, paste it. We'll first copy paste it here. Okay, then we'll copy paste it here as well. So till now, actually I've noted down all these things. All I have to do is I just have to run it. So you can see that the median is 30, the minimum value is 10, the maximum value is 50, and the first quartile and second quartile is 20 and 40 respectively. Okay, so now you can add multiple arguments as well, multiple attributes. So if you want to name this particular thing, name this particular box, okay, so what you have to do, you have to pass labels is equals to, you have to pass this parameter along with your data. Okay, so we have to write labels is equals to, and we have to make a suitable heading for it. You can see like you can write marks 1, sort of like that. Okay, also if you want to change the width of this particular box, you can change the width by using another attribute, that is width. Okay, and if you yeah, let's first of all let's run this particular thing. Yeah, so you can see that the width get changed, and the marks, you can see that marks 1 is written over here. Okay, now sorry, if at all you want some notch like box, okay, all you have to do, you have to pass the parameter notch is equals to true, and it will do fine. And if you want to draw a box that is parallel to sorry, this particular thing has a y-axis, and if you want this particular thing to lie somewhere like this, that is parallel to x-axis, you have to also pass an argument, that is vert, and you have to pass the value false to it. Okay, so what it will do, it will rotate it 90 degree. Okay, as simple as that. So what we are doing, we are mentioning the label name. By label I mean to say this particular box name. We are changing its width, and we want a notch sort of scenario. Notch means that there will be some notches here and here. Okay, and we want to tilt it 90 degree. So let's quickly run this particular code. Yeah, so I hope it makes sense now, right? These are all the notches. Okay, so till here I guess it is clear. So now I want to display multiple box plot together. So in order to do it, we have to provide them a 2D array or 2D list. So right now what I'm doing is I am importing, as simple as that, I'm importing matplotlib.pyplot as plt, and I'm creating a 2D array, and I'm passing it to x. Okay, so all these things, and I'm individually labeling them, like the first list named Archin, similarly Dinesh, Kafya and Vinay respectively, and I'm passing the X label, I'm passing the Y label. It's as simple, same thing, nothing much. I'm passing the title, and let's run it. Okay, so we can see that I'm getting individual box plots for these labels, that is Archin, Dinesh, Kafya and Vinay. Okay, so you can see these are some points here. So these points are called outliers. So let's quickly look into the figure. So if a particular thing is called minimum, if at all it followed this particular rule, okay, that is q1 minus 1.5 into IQR, that is interquartile range. Okay, similarly a maximum is calculated like this. So if at all this particular value is less than the minimum, these points will be called as outliers. Okay, if at all a point that is greater than this particular range, it will be known as outliers. So in a list, if the minimum value is less than this particular formula that we are getting, okay, I hope it makes sense. Listen to me very carefully. So in order to find out if there is any outlier, you have to first calculate this formula. You have to check in the list that if at all any number is less than this particular thing, it will be known as outlier. Okay, so in the same fashion, you have to first calculate this particular formula. Q3 stands for the 75th percentile plus 1.5 into IQR. IQR stands for interquartile range. Okay, you have to calculate it first, and if at all any number in the list is greater than this particular thing, it will be known as outliers. Okay, I hope it makes sense now. Okay, so these are all outliers. Okay, so we can see that 90, we are, yeah, so 90 and minus 30, these are all outliers. This particular thing is concentrated and these are all outliers. Okay, in the same way we can see 90 here and these. Okay, I hope it makes sense now, and I hope there is no doubt in Boxplotlib. Yeah, there is another there is one particular parameter or I can say attribute that you can pass, that is patch artist. What it does is it actually give color to your box. Okay, so I'll pass it, I'll make it true. Patch underscore artist is equals to true, and let's run it. So you can see that our box changes to blue. Okay, so I hope there's no doubt in this particular thing. Let's quickly look into Matplotlib heat maps. Okay, so a 2D heat map is a data visualization tool that helps to represent the magnitude of the phenomenon in form of colors. Okay, see, similar to CMap, heat maps is kind of similar to CMap, but here we are dealing with 2D. Okay, so a 2D heat map is a data visualization tool that helps to represent the magnitude of the phenomenon in form of colors. Okay, in Python we can plot 2D heat maps using Matplotlib package. So the thing is, Matplot does not have a dedicated function for heat map, but we can build them using Matplotlib's imp show function. Okay, same thing we are doing. We are importing numpy as np. We are importing matplotlib.pyplot as plt. I'm passing random data here. So let's print the data first, and I'm gonna comment all these things now. Let's take a look into the data. Okay, now you can see that I'm getting a data in the form of, I'm multiplying it by 100. Yeah, you have to make sure that I'm multiplying it by 100. These are overall 12 in 12 cross 12 matrix, and the range of this particular matrix lies between 0 to 100. Okay, so this is a 12 cross 12 matrix, and individual value will have a range from 0 to 100. Okay, so now we are using imshow function. Okay, so what we have to do, we have to write plt.imshow. We are passing our data and we are using a CMap here. CMap is Virdish. I hope you know what Virdish is. Virdish is a CMap where the 0th line or the 0th level represent the purple nature of the color, and the maximum, that is 100, denotes the yellow color. Okay, and it shows the transition of it. Okay, now I'm making a title that is 2D heat map, and I'm just plt.show. Let's look how our data is looking. Let's comment this particular section. Okay, now we can see that these are all bunch of heat maps. Sorry, these are all bunch of colors we are getting for individual blocks. So 0, 0. Let's first find out what this particular value contains. So it is 0, 1 and 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5, 6, 7. So 1, 7. Oh, I have to print the data. I'm so sorry. Let's print it. Okay, let's look into 97. Okay, let's calculate. So it should be yellow, somewhere very close to yellow. This is also yellow, and this particular thing is also yellow. Okay, let's look into this particular thing, that is 1, 0, 1, 2, 3, 4. It is very yellowish type. So let's look 1, 0, 1, 2, 3, 4. Okay, so we can see that it is bright yellow. Yeah, I'm so sorry. This is bright yellow, and this one is also yellow. So it is 99 and 98. And let's look into this particular thing, that is 0, 1, 2, 3, 4, and the last value of it. So 4 and last value, it's dark purple. Okay, so I hope you got the understanding of this particular heat map. Okay, so the conclusion is Matplot doesn't have a dedicated function for heat map, but we can build them using imshow function. You have to remember this fact. Okay, imshow function, we can do this. I hope it is clear to you. Now let's look into Python pandas plotting data with Matplotlib. So first we have to load the data. So I hope you guys are familiar with pandas. Okay, so how we do that, do the loading part, how we load the data. We have to first we have to import certain libraries like NumPy, Pandas, and Matplotlib. And in order to load the data, we have to make sure that we import Pandas as PD. Okay, so now let's make a variable or an object, that is df. Df stand for data frame. So I've given a shortcut as data df. Okay, and we have to write the command that pd dot read underscore csv, and we have to pass the file name over here, and it will read the data from here. So let's first look into the shape of the data frame. Okay, so it is 500 rows and 6 columns, and let's look into the info. So these are all the column names, that is serial number, NEET score, CET score, college rating, CGPA, and chance of admit. Okay, so these are all the columns present in this particular data frame, or in this particular CSV file. Okay, now we really know there is no need for us to get involved in serial number, so we'll drop this particular column. So how we do it, if we have to pass df is equals to df dot drop, we have to pass the column name, and we have to write x is equals to 1 because we want to eliminate the whole column. Okay, column wise we have to eliminate, or we have to drop the particular column. So what we have to do, dot drop, and it will remove this particular thing. Okay, now we are also naming them. We are assigning new names for it, so that it will be convenient for us. So NEET score becomes NS, similarly CET becomes CS, college rating becomes CR, CGPA becomes CGPA in small, and chance of admit becomes chance only. Okay, so what we have to do, df dot rename columns is equals to new name, same thing, and in place is equals to true. I hope there is no need for explanation because it has been taught to you in previous Pandas section. So okay, so now let's take a look of top 5 values in the data frame. So these are all the values. NS stand for NEET score, similarly CET, college rating, CGPA, and chance. Okay, so you can see that this particular column gets removed. Okay, Now we'll try to plot it, okay, individually. Let's plot it. So what we have to do, I'm using a loop here, and we are passing the values from 1 to 5, and it'll plot a box plot in each scenario. Okay, so this is not much. I think you guys know how to do it, but let's take a look into subplots. So what it conveys that this particular figure has one row and 5 columns, and we want to use ith column in it. Okay, so for one it will display here, the if for second it will display after one, similarly. Okay, same in the same fashion it will do. And we are providing the title name as df dot column. It will provide these names, okay, along with the box plot. So we are plotting the data in these individual columns. So it will the what box plus plot does is it actually displays the maximum, minimum and quartile values. Okay, so same thing we are doing, df dot columns, okay, and it will display the content in this particular column. Okay, so let's not describe df. Okay, let's try to plot it. Okay, so these are all the plots we are getting. So one thing you can see that these plots are colliding with each other. Yesterday also I hope you guys remember that there's a scenario where two figures are colliding with each other. So how to tackle it? By using figure method. Okay, so what you have to do, you have to write plt.figure, you have to pass 1 over here, comma, fig size, you have to pass a parameter or the attribute in it, and you have to mention the inches. Okay, so this is 18 inches and 7 inches. 18 inches horizontal, 7 inches vertical. So it'll mention, or it'll specify these 18 inches and 7 inches over here in this figure. So let's quickly run it. So now you can see it, 7 inches and 18 inches. So you can clearly see that now it is very much clear these figures are not at all colliding with each other. Okay, so you can change it to 12. So yeah, so still they are colliding, so I guess 15 will do just fine, and 5 also will do just fine. Okay, play with it, you'll get the fair understanding of it. Okay, so I hope it is clear to you till here, right? Now what I'm trying to do is I'm making a histogram. So what histogram is, we have seen in the previous lecture. I'm gonna uh, tell you a little bit about histogram, revise it. So the histogram basically represents the frequency for a given in a given interval. Okay, this is all about histogram. Okay, so what we are doing here is we are df dot hist. What it will do, it will take individual columns, and it will make a histogram out of it. Okay, and I'm using this particular show method to look into the graph how it is looking. Okay, yeah, so we can see that these are all the things with respect to all the histograms of NEET score, CET score, the college rating, CGPA and chance. Okay, so you can see that these are also colliding with each other. So what you have to do, you have to just pass the parameter over here, and we are good to go. Okay, so it is very much clear now. Okay, I hope you got my point. These are all histograms. Okay, so let's look into a very important thing, that is calculate correlation between each column and chance of acceptance. Okay, yeah, so the question arises, why correlation? Correlation is very important in order to find the most important feature in the columns and the least important feature in the columns. So it is very evident from this graph that CGPA tells more about the chance, and the college rating is the least important feature here when it comes to acceptance. Obviously, since we are plotting it with respect here, we are plotting it with respect to chance only, so the correlation value is 1. So ignore this particular bar, and let's focus on these 4 bars. We also see that the neat score is having a little bit more importance as compared to the CET score. So this is how we all correlate the data, and how we do it. We have to first pass, we use method core, and we have to pass this particular column name because we are trying to find the chance of acceptance. Now we are plotting the bar graph. What we have to do, we have to pass all the columns. Okay, we have to pass this particular thing df.core, and since we are storing it inside correlation, we have to pass correlation, and we have to it depends on us whether we want a red color bar or a green color bar. Okay, so it depends on us. Let's write olive. Okay, let's print it. Okay, and if you want to show the correlation values, you can just write it, and there you can see that ns is 0.81, CS, that is CET score, is 0.79, and similarly. Okay, so I hope it is clear. It is very simple, but it is one of the most important terms, correlation, when it comes to machine learning. Okay, now talking about style plot in Matplotlib. So there are various built-in styles in style package, and we can also write customized style files as well. Okay, so what we have to do, we have to first import matplot.pyplot. Okay, similarly we are importing, this is very important here. So we, from Matplotlib, we are importing style. So what we have to do, write from Matplotlib import style. Okay, so in order to check how many styles we have, so what you have to do, you have to write a print statement, and inside it you have to pass plt.style.available, and this will okay, let's run it, and let's first, okay, let's run it. So you can see that there are various styles available. One is classic, dark background, fast, 538. It is very famous style available, and similarly a dark background color as well. Okay, so these are all the styles available. Now let's generate random numbers. Okay, and let's see the data first. So you can see that we have generated random numbers, random 50 numbers, and let's write this particular statement, that is plt.style.use. So we are specifying that we want to use dark background in this particular scenario. So what you have to write, you have to pass plt.style.use. Remember this, plt.style.use, and you have to pass the style you want to use. So it can be dark background, fast, 538, anything. Okay, now you are plotting the data. Okay, it is easy, plt.plot, and you're passing the data, and let's run this particular thing. Okay, so you can see that this is particular graph we are getting, and style we are using is dark background, so you can see that the background is very dark. And okay, I think it is evident to you. Now let's comment this particular section, and let's print a sine wave. Okay, so I hope you guys know how to generate a sine wave. So this particular thing we use, okay, we have to use numpy here. So I hope you guys already know it. Okay, and what you have to do, let's change the style to, let's say, 538. Okay, let's copy, let's paste it here. Okay, I have to put it in quotes. Let's run it. So you can see that we are getting a line, a sine wave. Okay, I hope it is visible. You can see that it is 0, 10, 20, 30, 40, 50, similarly. Okay, so this is all about style. It is not an important library, but yeah, you can add style. Okay, so this is it about styles. Now what we are trying to do here is we are plotting data in real time, and it is one of the most important feature in Matplotlib. Up till now we have seen that we are working with static data. So what we are doing is we are passing an array that is predetermined. Okay, we are not dynamically plotting the data. So this particular code will tell you how we can do it. Okay, So this is per last section. I can say that last section of Matplotlib, and afterwards you can see that I'll be teaching you guys Seaborn. So those who are interested to learn Seaborn can stay, and otherwise, if you are attending just for the sake of completion, you can just leave from here, leave the lecture. Okay, and but I request you guys to please attend Seaborn because it is very important. Okay, so I'll be just giving you the glance of Seaborn, not teaching you in depth, and I'll hardly take 15 to 20 minutes more. So please stay with me. I'll first discuss about this code. This code is very important, and later on we'll move into the Seaborn library. Okay. Yeah, so let's see what this particular code is doing. So what we are doing is we are importing random. Okay, so we have to write import random. Okay, now from iter tools is a module that provides various functions that work on iterators to produce complex iterators. Okay, there is no need to know about this particular module in detail. All we have to do is we have to concentrate on this particular thing, that is import count and what it is doing. So I'll be explaining you what count is and why we are importing count in the later part. So let's first see what else we are doing. So we are importing pandas in spd, and we are importing matplotlib.pyplot.splt. Okay, I hope it is clear to you now. Up till now we have seen that we are working with the static data. So what we were doing is we are providing data like 0 1 2 3, okay, 3 3 6 3 4 6, okay, like that, and we are passing static data in y values as well, like 12 36, sorry, 56 23 78, and the size should match, so 65. Okay, and we are just plotting it. So in order to plot, we are writing plt dot plot, and we were passing the arguments. Okay, let's run it. So we can see that since we are using a style that is background style background, so it is showing some dark background style, some dark background plot. Okay, so I hope it is clear. Till now we are working with the static data. Now what we are doing is we are concentrated to build a plot that works on dynamic data. So that's why we are importing count from iter tools. So this particular thing, what it does is it by default it counts one number at a time, and each time we get a new value or the next value. Okay, like 1 2 3 4, like that. Okay, and what we are doing is we are creating a function. Okay, that is def. We know that in order to create functions in Python we have to write this particular syntax, and the function name is generate, and we are passing I here, and it will start from 0 1 2, so something like that. Okay, now we are working here with we are see this particular statement, what it does is it's actually appending the data. Let's first clear these arrays. So these arrays are empty now. Xvel and Yvel arrays are empty. It does not contain anything. And what we are doing is we are generating numbers using this particular thing, count, and generating sequential number. We have to it is generating sequential number, not a random number. So in a fashion like 1 2 3 4, like that, and we are appending it to our array, the array that are empty. Okay, so it will start from 0 or 1. I'm not sure of it. We'll find out what it will start from. Okay, now similarly we are appending some random numbers in between 0 to 5 inside the well array. Okay, I hope it is clear to you. And what we are doing is we are plotting it. Okay, so in order to invoke this particular thing for a certain interval, what we have to write an instruction, and in order to do it, okay, in order to do it we have to write this particular statement, that is from matplotlib.animation import funcanimation. What it does, it actually enables us to run this function every second and plot this value and append value to the next. Okay, so in order to make use of this particular library, we have to write a statement below the function, that is a name is equals to func animation. Okay, and we have to pass a method that is plt.gcf. Okay, gcf stands for get current figure. Okay, and we have to pass another argument, that is the name of the function, this particular name, that is generate. Okay, let's copy paste it, and we have to mention the interval, so interval equals to 100. Okay, I hope it is clear. Interval equals to 100, that's 1000, sorry. So 1000 here signifies that this particular thing is in milliseconds. So basically we are generating a number, we are invoking this particular function every second. Okay, so in order to do it, we have to write this particular line, and that's it. Okay, let's run it. Okay, so yeah, so I'm getting nothing here. So in order to see this particular thing, you have to write an extra line here, that is an extra line, that is matplotlib. Okay, run this again and you can see that. Yeah, so I hope this screen is visible to you. I hope the screen is visible now. Yeah, so you can observe that the color of the plot is changing each time, and it happens when there are multiple lines getting stacked over each other. So what I mean to say is the particular library is not clearing its old data, and that's why we can see the color is changing. So in order to clear the previous access, we have to write a function. We have to write a method called plt.cla inside the function that we have created, the generate function, and we'll are good to go. Okay, let's quickly see. Yeah, so what we have to write, we have to write plt.cla. Okay, and CLA stands for clear access, and will again plot the curve. So now we can see that there is no change of color, and each time a new plot is getting created and the older one gets removed. Okay, so I hope it is clear to you guys. Now let's take a look at Seaborn. So Seaborn is used for data visualization, and it's based on Matplotlib. Basically, Seaborn is built on top of Matplot, and Seaborn allows the creation of statistical graphics. Okay, so the question comes, why Seaborn if we have a library called Matplotlib? Then why there is a need to make another libraries on top of it? So basically there are two shortcomings of Matplotlib. The number one is Matplotlib settings are difficult to figure out. Okay, and the other one is Matplot doesn't serve well when it comes to dealing with data frames. Okay, this is one of the very important shortcomings of Matplotlib. So Seaborn function actually works well on data frames, and Seaborn comes with numerous customized theme and high-level interfaces as well. So these two shortcomings is overcome by this particular library, that is Seaborn. So how we import Seaborn? So we have to write a command, that is import Seaborn, and as SNS we have to write SNS. Similarly, if we are importing from Matplotlib, we are importing pyplot, or we can write it as import matplotlib dot pyplot as plt. And Seaborn actually provides a number of data sets, and fMRI is one among them. So in order to load the data set, we have to write sns dot load underscore dataset, and we have to mention the name of the dataset, that is fMRI. Okay, and this particular thing we are storing it in fMRI, and we are printing the first 5 rows of this particular dataset. Let's run it. Okay, so you can see that we have subject over here, time point, event, region, signal. Okay, these are all the things here. Now in order to plot a line between time point and signal, okay, what we have to write, sns dot line plot. This is one of the methods, and inside here we have to pass the argument, that is x is equals to time point, that is this particular column, y is equals to signal, this particular column, and we have to pass the data as well. So data is equals to fMRI. Okay, this particular thing, right? And let's plt.show. Let's run this code. And I know you guys are not able to see the screen, but what I can do is I will go and first I'll remove this particular line. Okay, I'll restart the kernel. Okay, so let's first, okay, it is loaded successfully, and now you can see the line that we are getting. Okay, so we are plotting it, the x-axis is time point, so there is no need to mention a label. Okay, you can just write time point and signal, time point and signal, and we are passing the data from fMRI. Okay, and these are all the data. Now in order to make a line point, okay, uh, depending on event, so we have to pass an argument, that is hue argument. Okay, so mapping an event onto we are trying to map this particular event. Okay, the time point and signal, we are trying to map it in accordance with the event. Okay, so you'll get a better understanding, a fair understanding of it when I run this particular code. Okay, so you can see that there are basically, if you take a look in this particular data set, you'll find that there are 2 types of event. One is stem and the other one is queue. So you can see that it plots for stem as well as for queue. Okay, the time point signal for stem is something like this. You can see that there is a steep or a large drop here as well. Similarly, there is small drop and small I think you can observe it very nicely that there is not much of a drop here. We can see that there is a high drop here. So this is all the difference between this happens when we use hue. Okay, and we have to pass a column name, that is I'm sorry, that is event. Okay, now we can also change this particular style in accordance with event. So let's, what we have to write, we have to pass another argument, everything is same, we have to pass style is equals to event, so it will change the style of this particular line plot. Okay, so now you can see that dashed line represents q and the color is also orange, and stem represents by the solid line. Okay, okay, so I hope it is clear to you. Now we can add markers as well. All you have to write markers, and you can specify what type of marker you want to use. Let's say ring marker we want to use, so it will mark the line, it will point the markers here. Okay, so it is very easy. This is just the basics of it. I just wanted to teach you guys Seaborn so that it develops more interest in you to learn Seaborn. It is very important library. Okay, now coming on to Seaborn bar plot, we have seen what bar plot is, so we'll be working on a data frame here. So the data frame here is admission prediction.csv. So let's first take a look at how the head of this particular CSV file. So we have to, okay, I'll come in this particular section, I'll come in this thing. Okay, let's run it. So you can see that this particular CSV file contains 1, 2, 3, 6 columns. serial number, NEET score, CT score, college rating, CGPA, and chance of admit. Okay, and we'll be working on this particular data frame. Okay, so what we have to write first, we have to read the data. So before that, we have to import pandas as PD, and we have to read the CSV file into a data frame. So this is df.head. Let's remove this particular statement now. Okay, now we are trying to set the style of our plot, so it is dark in nature. Okay, now we are using bar plot. So in order to use bar plot, we have to write sns.barplot, and we have to pass the argument here. So in x-axis I'm giving college rating, that is 432, and in y-axis I'm giving the CGPA of that particular student. Okay, now let's first ignore this line. Okay, and I'm passing the data that is stored in data frame. Okay, df, sorry, and let's show this particular thing. So you can see that we are able to see various college ratings here and the CGPA. More the CGPA, the better the chance to get into the college rating, higher college rating. Okay, into a college having higher college rating. So I hope it is clear to you. This is all about bar plot. Okay, I'm not gonna emphasize more on Seaborn. I'm repeating it again and again. I just want to give you an insight of it. Okay, so it is very easy to handle pandas, as we have seen that it actually overcomes, while Seaborn function actually works on data frame very well, and Matplot doesn't so well. We have seen that we have to do multiple things in order to use the data frames there. Okay, so this is all about bar plot. Now we have let's quickly see what scatter plot is in Seaborn. We know that what scatter plot is. We are trying to, in very basic term, we know that scatter plot is we are trying to plot dots in the graph. Okay, so scatter plot can be used with several semantic groupings which can help to understand well in a graph. They can plot two-dimensional graphics that can be enhanced by mapping up to 3 additional variables while using the semantic of hue, size, and style parameters. Okay, so we'll be working on iris data frame here and iris data set here. So I have to read first of all, and in order to read the CSV file, I have to pass pd.read underscore CSV, and I have to pass the file name here, and let's see the head of the iris data. So we have ID over here, we have sample length in centimeters, sepal length centimeter, sepal width cm, petal length cm, petal width cm, and the species. Okay, now let's plot a scatter plot. So in order to plot a scatter plot, we have to write sns.scatterplot. We have to use this particular method, and I'll be passing here sepal length and petal length, and I'll be passing the data. Data is from iris, so this is the thing that we have mentioned. And hue, I have already tell you what hue is, and style is also according to the species. Let's quickly plot this thing. So yeah, you can see that there are 3 species. Okay, and according to it, I'm using hue and style here. Okay, so you can see that the more the sepal length is, the more okay, so it is a linear relation. Okay, I can figure out that it is somewhat a linear relation here. Okay, so this is all about scatter plot. So here we are determining the color with respect to a categorical column, that is species. Okay, we can change this particular thing to a numerical column, while all we have to do is we have to pass the petal length to the hue, and we are good to go. So let's quickly run this particular code. Now you can see that if the petal length is less, it will be a faded color, a creamish color like this, and if the petal length is more, that is 6, it will show a dark purple color. Okay, I hope it is clear to you. Okay, and let's quickly look into distribution plot here. So it is used to draw a plot of two variables with bivariate and univariate graphs. Okay, so I hope it is clear. So in layman terms, a distribution plot is a combination of histogram and the frequency curve. You have to remember it. I'll type it here. Combination of histogram and frequency curve. Okay. I forgot. Okay, now it's clear. And for this, we are using another, I can say data frame, or I can say a CSV file, that is diamonds. And I'm reading it using Pandas. I have already imported the Pandas library here, so there is no need to import it again and again. So if you have to write df is equals to pd dot read underscore csv, and I have to write the file name over here. Okay, and let's check out the first 5 rows. Okay, okay, I should comment these sections. So you can see that there are various columns here, and that is caret, cut, color, clarity, depth, table, price, xyz, that is length, width and height, if I'm not wrong. Okay, all the dimensions. So let's plot this particular thing. Okay, so in order to plot this particular thing, we have to write sns dot dist dist plot, and we have to pass the uh, a column here. So we are passing price column here. So let's quickly look. Okay, so yeah, this particular thing, you can see that this particular version is very old, and it will be removed in the future, so just ignore as of now. Now you can see that there is a frequency curve. Okay, this is the frequency curve, and this is the histogram. So I have already mentioned that combination of histogram and frequency curve. Okay, now you can set number of bins here according to your need. So if I want 50 bins, all I have to do is I have to copy it, I have to paste it. Okay, and place a comma in between. So now you can see that these are all 50 bins, and if you want to remove this particular thing, this frequency curve, if you want to remove it, all you have to write is kde is equals to false, and it will remove the frequency curve. And in order to remove the histogram and we just want to see the frequency curve, you have to write hist is equals to false, so you can see the frequency curve over here. Okay, you can change the color, and if you want to change the axis of this particular graph, you have to pass vertical equals true. Okay, now you can see that the axis gets changed here. Okay, and let's change the color. Okay, let's change the color to hot pink. Let's run the code. You can see that we can change the color of this distribution plot. Okay, so all in all, you have to remember that we have to pass dist plot, that's it, nothing else. Okay, let's look into joint plot, and it is used to draw a plot of two variables with bivariate and univariate graph. So basically a joint plot is a combination of scatter plot and histogram. So I'll write it here that it is a combination of histogram and scatter plot. Okay, so all you have to do is you have to write a method called sns.joinPlot, and you have to pass the parameters, that is sepal length cm, and since we are working with iris data frame, so we have to pass sepal length, petal length, and passing the data iris. Okay, let's plot this thing. Now you can see that we have petal length over here, we have sepal length over here, and these are all the histograms with respect to petal length, a histogram with respect to sepal length. So it is a combination of both. You can also do kind is equals to regression. Okay, so it will give you a regression line. Okay, I'm not telling you what regression is because in the upcoming lectures you get to know of very much detail about what regression is. So it's right now what we are trying to do is we are trying to make a line here, a regression line for this particular scatter plot and this particular regression, sorry, histograms. Okay, so this is the thing that you have to keep in mind. Coming to the pair plot, this is the last topic. So it represents a pairwise relation across each data frame and supports an additional argument called hue for categorical separation. Okay, what it does basically is create a joint plot between every possible numeric column and take a while if data frame is really huge. So this particular thing is very important. What it does basically, it create a joint plot between every possible numerical column and take a while, and if the data frame is huge, it will take some time. Okay, that's it about pair plot. Now I've copy pasted the code here and let's see what we are doing. We are importing Seaborn as SNS, we are importing Pandas as PD, importing Matplotlib.pyplot as VLT, and I'm using a style here that is ticks, and in order to do it we have to write sns.set and I have to mention the style over here. Okay, so there is no need. First let's take a look at the iris head first. Okay, control C, control V, and I'm gonna comment these particular sections over here. Okay, invalid syntax. Okay, now we can see that this particular thing is the data frame or the first 5 rows of the iris dataset. Now let's remove this line, and there is no need for this particular column, that is ID, so I'm gonna drop ID from it. I'm gonna choose the style as text. I'm gonna drop the column ID axis equals to 1. That means I do not want that particular column, and let's not, yeah, and let's plot iris data set first. Okay, so in order to pair plot, I'm gonna repeat it again. What it does is it actually create a joint plot between every possible numerical column, so between sample length, sample width, petal width individually. Okay, a joint plot between every possible numerical column. Okay, so let's run it. Now you can see that we have sepal length here as y-axis for all this particular four figures, and similarly petal width, petal length, petal width, sepal width it is. Similarly, we have sepal length, sepal width, petal width. These are all four numerical data, and it is the graph. What pair plot does is join plot between every possible numerical column. So it plots the graph between sepal length, sepal length, sepal width is this, sepal length, length is this, and sepal length, petal width is this particular thing. So now we can add various things inside pair plot to make it look more attractive. So we are using hue and we are passing species over here. There are 3 types of species, we know that. And palette, oh, I forgot to mention what palette is. Palette is one type of a style here. Okay, so yeah, let's first add this particular thing and you'll get a fair understanding of it. So let's add this thing. Okay, so palette glued. So let's run it. So you can see that it is actually showing a transition of colors a color that is blue. Okay, so a light blue is here, some kind of blue is here. Okay, depending on the value of it. Okay, so we use palette blue. Okay, there are several palettes. I'm using blues underscore D in this particular scenario, and I'm using HUSL in this particular scenario. Okay, so I'm giving the markers for individual species, that is 0 for one of the species. 0 means sorry, O means ring here, S stands for square, and D for diamond if I'm not wrong. Let's Okay, so I've already, yeah, deleted this particular thing, so there is no need to do it again. It'll take some time if the data frame is huge. Okay, so hold your horses. Yeah, so you can see that we are getting various nice plots over here. These are all known as pair plots. Okay, so I hope this particular thing, that is pair plot, is clear to you, and this is all about the insights, or I can say a quick glance at Seaborn library. And this is all from my side. Thank you for being a patient listener, and I hope you guys have followed me till here. And if at all you have any doubt, you can ask me over uh, in the comment section. You can ask me, you can WhatsApp me in the group, and you can WhatsApp me directly as well. There is no issue. So that's it from my side. This is Aayush Porwal signing off, and have a nice day. Thank you.